Decision tree. Decision tree, what do we understand by the name? Decision tree is something, it is like based on some parameters, we try to predict or we try to take judgment on one particular variable, let's say the dependent variable. So decision tree gives a tree kind of approach where we know that if something do not happen or some particular procedure happens, then in what way the tree goes like, what way the decision goes like, and how we can reach on or predict the decision based on our data. A decision tree is a tree-like structure in which internal node represent test on an attribute. Each branch represent outcome of test and each leaf node represent class label. That is decision taken after computing all attribute. A path from root to leaf represent classification rules. Thus a decision tree consists of three types of nodes: root node, branch node, and leaf node. So what we can say the root node, this is the root node, like from where that start. What are the branch node? These are the branch node, and these may be considered as a leaf node, and it can goes on. So if you look at that, it is a kind of binary tree where one root node is dividing into two children node or branch node. Like if we have a dichotomous variable, so true may be one category and false may be the other category. So true will go like this and false will go like this based on different other attributes. So the structure is of the tree structure is like that. How to build decision tree? Use training data to build model. We always work on the training data. Whenever we have a data set, we convert that data set on training data and test data. So that's a usual practice we do. We do for all the machine learning concepts. Tree generator determines which variable to split at a node and the value of this split. Remember that. We are talking about how a tree is generated, like you provide the value, but based on that value, how a particular tree is start with root node and then divide it into a branch node and more branch node into deeper and deeper. So the question is which variable to split at a node, at a root node, then at a branch node, and at what value it's going to be split. Can we control that value? Do we assign that value, or it's not in our control at all? Like algorithm is not written in that way. So that is the question. We'll deal into the due course of this class. Second important question might come in our mind, that decision to stop. Where to stop this tree? Like at what point we do not get more of the branch node or more of the leaf node, and assign terminal node to a class. How to do that? So we have a sample data for us to look at the analysis. So look at this data. We have a REC, that may be the record ID. Age is basically converting into 3 bins: less than 30, 31 to 40, less than 30, 31 to 40, and greater than 40. Okay. So in the same way, income is divided into 3 bins, 3 category: high, medium, low, medium. So basically 3 category: high, medium, and low. A student is whether is a student or not, no and yes. Credit rating, bias computer, no and yes. So assume that we need to predict that whether a particular person whose in age is less than 30 or income is high, he is not an student and he has a fair credit rating. What is the chances that he will buy the computer. What is the probability that he will buy the computer or not? So buys the computer is, we can assume that's a dependent variable that we need to predict. Okay. Now, question is like, if we draw the tree can be started from age or from income or from a student or from credit rating. But which trees to choose and how the algorithm choose that what variable would be at the root node or the starting node. So for that, let's move on with the example. Let's say we start, the tree is started, we design the tree taking root node as a student value. So we have two categories in the student, whether it's a student or whether it's not an student. If he is not an student, we have a data for that particular category. Okay. And if he is a student, we have a data. We have segregated the data into two groups. Okay. So now our objective is to find out whether he will, this class, whether he will buy the computer or not. Okay, in both the situation. So now, and at this point of time, this is a root node and these could be the branch node. But branch node would be, split with which variable? Based on the CR rating or based on the income or based on the age, in both the cases. Okay. Or the question is whether if this student, then no node split at income, does the same happen with the income variable here, or this node, the right node, can be split based on CR or based on age? Okay. In this case, look at that. A student, he was not an student, but he falls into high income category, and this is the situation for him. Income medium, like in no, there were only two medium and high group category. In yes, there was three category for income. So tree is going splitting like this. Okay. If you look at these two cases, it's yes and yes. Like there's no ambiguity in the decision that whether they buy the computer or not. We are very much sure. Only here we need to split. We need to figure it out. Still, we do not reach on a conclusion whether he is buy a computer or not, because both the situations are there. In this case, we have both the classes. Even in this case, we have both the classes. So what we are doing, we are splitting. We reach into the situation. So what we understand that if a person is not, he is a student, but he falls in the high income group, he will definitely buy the student. If a person is a student, but he falls in the medium income category group, even he will buy the computer. But still we are not sure about whether he is a student and falls in the low income group, he will buy or not. So we need to split it here, here and here. Okay. Right. So even we split the tree. Based on here, it based on CR. If he is not an student, income is median, then it's further split based on CR, credit rating. But if he is not an student, falls in the high income group. Now the branch is split at the in the based on age. So what we understand through this tree, we understand that the branch node not necessarily that always, like in this case, always split based on common variable. The split may be based on different variable, but ultimate goal is to reach, to figure it out whether he will, to predict the dependent variable, whether he will buy the computer or not. Okay, so that's a very good example that is written there. Okay, so if you look at that, here we have reached this conclusion. Here we have reached the conclusion. So what we can say, if a person is not an student but falls in a high income group and his age is greater than 30, he will not buy the computer. Whether he is not an student but falls in a high income group and age is between 30 to 40, he will buy the computer. Okay, but still if he is not an student and falls into the medium income group and his credit rating is fair, still we cannot say that whether he will buy or not. So it can further split based on age. Okay, it can further split based on age, that we can understand. But here we have reached on this situation, whether he is an student, falls in the low income group and is an excellent credit rating, still we are not sure whether he will buy the computer or not. Okay, so now as we have a data limited to 14 rows, it's easier to draw this model using pen and paper, using our own capacity, and do that. But imagine there are lakhs of millions of rows and there are number of columns are more than 2, maybe 20, maybe 15. Then we have a algorithm, we have a mathematical model to do all these things on its own, so that we could take the decision. So do we have those capability in the algorithm, in any of the R package or not? And if we have that, how to read the decision or the decision tree given by the algorithm, that we will discuss. That is the discussion objective. Okay. Right, so that's step 5, and that is the final step. At the final step, we reach onto the conclusion that whether what would happen, what would be the objective under the different scenario, right? That is something we can do by when we have a 14 rows or maybe 100 rows, but definitely it would be difficult to do when, or impossible to do in, if we have lakhs of rows. At which variable to split exactly? Yes, Abhinya, that we will discuss. But like when there are very less rows, we can decide on our own. So if you go back, let's go back from here. Let's try to understand that once again. We have started with student, okay? Can we start not with student but age or income or credit rating? Yeah, we can do that. No problem in that. It's not that we can only start with student, right? Okay. But what we can do, if we do not have a mathematical model, what we can do, we can start with a student and then draw a tree. Then again we draw a next tree using the income variable as a root node, age variable at a root node. Or should we go with the variable which has maximum correlation? We have a different concept here. Okay, we have a, yeah, we can do that. Where you see there's a high category, so that is one way to take that. You are very much right in that. Okay, so whenever you see a there's a high category, we can do that. But if you talk about the correlation, we are like there is a 1. If we convert that no into 0 and yes into 1, then only we can find out the correlation. But correlation has not much sense here. We have a different concept called entropy here we looked at. Okay, but when we do it on our own without using any mathematical model, we can start with income as a root node, age as a root node, student as a root node, or credit rating as a root node. But what the final tree will choose? Will choose the final tree through which we have we have the answer, we have the predictive power with the minimum number of split. Okay, so here we start with the student. So if you look at that, now these two nodes, student when no student and yes student, I can divide this based on age as well. Okay, or based on category CR as well. Yes, we'll discuss that. We'll discuss that. Let me come to that. Let me come to that. We'll talk about it. Okay, so in this way we can move on. Right? So that is the thing, that is the tree. We started taking student as a root node. Okay, so what we have a classification rule: if no student but falls in the high income category and age is less than 30, he will not buy the computer. That is the classification rule we got from the tree. Similarly, we draw another conclusion: if he not an student, falls in the high income group, age between 31 to 40, he will buy the computer. Okay, similarly we have the different association rule based on the branches, based on the branches that the tree has from root node to end node. But what if we started with a different root? So in this step we tried to explain the same data set using decision tree by taking income as a root node. Okay, income we have 3 categories: high, low, and medium. So we have 3 root node, 3 branches we start with. Okay, now again we need to decide that which branches, how it will go on. So income, like the high income, we divide it based on the age. So if age is less than 30, we can say that he will not buy the computer. Age is between 30 to 40, we can say that he will buy the computer. If he is a medium income group and the category is student, he is not an student, we are not sure yet. He is an student, then we can say that he will buy the group. If he falls into the low income category but fair credit rating, he will buy the computer. But if he is an excellent credit rating, we are not sure. So we are not sure in 2 situations. That means still this tree has to grow further. Right? So in this way there's a full grown tree where we reach on the conclusion. But in real life scenario, we cannot reach on the conclusion till the last variable, because there are, I say that lakhs of rows are there. Then in that scenario you cannot reach on the last node, where at the last node you have only 1 row, 1 data left. Okay, under that situation you have to have some probability concept or some minimum binding concept, bucket concept, that I want my tree to take decision if he has a minimum number of items present in the last bucket, or the bucket size. Bucket I am calling this one. Let me tell you through a spot, right? This is the bucket. Here the bucket having only one, data, but at least because when the data set is large, it's not possible to start from the root node and reach to the end node till we have the exact result. Then what concept we use, how we decide that? Okay, so we have a classification rule on decision tree 2 where the root is income. Okay, which tree to choose? That's a very important concept. Which tree? I mean, the tree is tree node where the student was the root node, or the tree where the income was the root node. So which tree to choose? The core algorithm for building decision tree called IDE3 by J.R. Quinlan, which employs a top-down greedy search through the space of possible branches with no backtracking. IDE3 uses entropy and information gain to construct a decision tree. Now the question is, what is this entropy and information gain? The topmost decision node is a tree which corresponds to the best predictor is called root node. So best predictor is that whether it should choose student as a best predictor or income category as a best predictor, something like that. What is information gain? The information gain is based on the decrease in entropy after a data set is split on an attribute. Constructing a decision tree is all about finding attribute that returns the highest information gain. That means the most homogeneous branches. Okay, because as the most homogeneous branches would be there, the tree would split lesser and it will reach to the conclusion faster. Okay, so that is why we use this information gain and entropy. Then how to calculate that information gain, entropy and gain? So this is the formula for entropy. Right, can't understand. Let me tell you. Okay, let me repeat. The tree to choose, which tree to choose? The core algorithm for building decision tree called IDE3 by J.R. Quinlan. So IDE3 is the algorithm name which is developed by J.R. Quinlan, which employs a top-down greedy search through the space of possible branches with no backtracking. IDE3 uses entropy and information gain to construct a decision tree. Now, what is this entropy and information gain? The topmost decision made in a tree which correspond to the best predictor is called root node, right? We know that. Like we developed our model based on two root node, one by taking student and the other time we're taking income. Now the question is which one is to choose, whether to choose student tree node or the income tree node. Okay, so we have the concept information gain and entropy. Entropy is a physics term. The information gain is based on decrease in entropy after a data set is split on an attribute. That means once entropy is what? In physics, entropy is called the randomness, or what I can say that entropy is a when the things are scattered, or what I can say that, okay, when you, let's say you I'm trying to explain you entropy. Let's say early morning, you clean your room, you put all the things at a proper place, and everything is at the proper place where it should be. Okay, then probably your little child woke up and he started throwing and keeping things here and there. So if I say the entropy of room before the child enters into the room, or entropy after the room after the entropy of the room after the child happens would be decreases. So entropy, do you understand? Entropy does what? It is something like that the things become more, disturbed, I can say, right? So entropy for the next situation has been increased. Increase in entropy means the information, there's more disturbance in the environment. Entropy, the information gaze is based on the decrease in entropy. That means after a data set split into an attribute, and if entropy is decreased, read this line properly. The information gain is based on the decrease in entropy after a data set is split on an attribute. So once the data set is split from root node or branch node and entropy is going down, entropy is higher means more disturbance. Entropy is going down means less disturbance in respect to the dependent variable. So we have if we can each dependent variable category more easily, that means the entropy is decreases, and that was the objective is. That is why the entropy is we look at it. That's a physics term, and it is said that after our universe is created, the universe entropy is always getting higher and higher and higher because more of the disturbance is going on. And once a disturbance comes into the environment, you cannot put back into the original shape, especially in the physics world. So which tree they want to choose? They want to choose the tree which has a less entropy. Less entropy means more robust, less disturbance. Less disturbance in terms of the root, the dependent variable. Okay? And this is the formula to calculate the entropy and then the information gain. So let's try to calculate these two measures using our data set that we have. So that is the information gain that I discussed. The information gain is based on the decrease in entropy after a data set is split on its attribute. Constructing a decision tree is all about finding attribute that retain the highest information gain. I mean the most homogeneous branches, because in that way we'll reach to the information for the dependent variable more more timely manner. So that is the formula. And if the sample is completely homogeneous based on dependent variable, the entropy is 0. That means now that cannot be divided. That sample cannot be divided further. We don't need to divide it. Okay, so what we are doing here, we are trying to calculate the entropy. Calculation of information gain for tree 1, root student. We are first trying to calculate the IPN, okay? And then at sub 1 and sub 1, sub 2 and sub 2, like these are the branches. And then we'll try to look at that, whether we can calculate that properly or not. So, okay. Where this IPN comes from? This is the formula for IPN, right? Okay. The formula for information gain and these things. So let's try to understand how to calculate these things. Look at that. We are talking about the calculation of information gains for tree 1, where the root node is the student node. Okay. So let's try to understand that. Right. Look at the student node. First root node, we took the student as a root node. Okay. In student as a root node, our dependent variable, predictor variable is bias computer. I took student as a new node. What is the word bias computer? How many nodes are there? 1, 2, 3, 4, 5 nodes. And total yes is 1, 2, 3, 4, 5, 6, 8, 9, 10. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 yes and 5 no. Okay? When I talk about the student variable, right? So let me reach there. Look at that. IPN is what? 9 upon 9 plus 5. 9 yes. 9 plus yes plus no. Log sub 2 into 9 upon 9 plus 5 minus 5 divided by 9 plus 5 log sub 2 5 9 plus 5. Okay, both have minus sign, so it doesn't matter you start with yes or you start with no variable, you end up with the same calculation. IP sub 1 n sub 1, IP sub 1 n sub 1, IP sub 2 n sub 2, and as we are talking about in student, so we are talking about the sub branch of this IPN, first branch and second branch, as this student is divided into two branches, right? Okay. If you look at that IP sub 1, how many nodes are there? 1, 2, 3, 4. 4 nodes, 4 no and 3 yes. Okay. So what would be the IP sub 1? Yeah, here it's represented by IP sub 2 and sub 2. 3 upon 3 plus 4. Wait a minute. 1, 2, 3, 4, 5, 6, 7. Total 7. Out of that 3, 9, 4, 9 and 3 yes. So what would be the IPN for this branch? Okay. What would be that? Minus 3 upon 3 plus 4 log sub 2 3 upon 3 plus 4 minus 4 upon 3 plus 4 log sub 2. So IPN for this branch is 0.987. What would be the IPN for this branch? How many no we have? One. Only one no. And 6 yes. So what it would be? Minus 1 upon 1 plus 6. Or minus 6 upon 6 plus 1 log sub 2 6 upon 6 plus 1. Right? We have a 0.591. So if student is a yes node, student is a root node, and we have yes, we have 6 in yes category, we have 6 yes and 1 no. 6 yes and 1 no, and what is the IPN at this node? 0.591. And at the no category, we have 3 yes and 4 no. What is the IPN for the subnode? 0.987. Okay. So what is the entropy for student? What is the entropy for student at this level? Entropy is that. What is the formula to calculate the entropy? This is the formula. So we are doing the same thing. We are trying to calculate the same thing here. Six plus 1 upon total 14 multiplied by 0.591 in this case. Okay, plus there would be a plus sign here, plus 3 plus 4 divided by 14, this total was 14 into 987. That will give us 0.789. So entropy, if we take student, what is the entropy? It's 0.789. What is the IPN? 0.987. What is the information gain in this case? 0.944, sorry, this one, 0.944 minus 0.987. So we have information gain 0.155. Okay. IPN will be same for each one, right? Now, IP sub 1, P sub 1, N sub 1, P sub 2, N sub 2. This is the calculation for the student node. The same way it will calculate IP sub 1, N sub 1, IP sub 2, N sub 2 and IP sub 3, N sub 3 for income, because income has 3 root. Income has 3 root. What would be the IP sub 1 n sub 1 for income. In this case, 2 minus 2 divided by 4 log sub 2, 2 divided by 4 minus 2 divided by 4 log sub 2, 2 divided by 4. That is IP sub 1 n sub 1 for this one. Similarly, IP sub 2 n sub 2 would be 1, 2, 3, 4. We have 4 yes here and 2 no. So what it would be? Minus 2 divided by 6 log sub 2, then calculation minus 2 divided by 6, something like that. You got it? And then it will calculate the IP sub 3 n sub 3 for each of the node, right? Then it will calculate the entropy calculation, like it will give in income. We have here, it will be written as income. There would be 3 rows. One would be written as high, low and medium. So high, low, medium. For each high, what is the P and what is the N, what is the IP sub 1 and N sub 1 for that, something like that. So it calculates for entropy and then it will calculate the information gain. Now it will choose, and imagine that this algorithm is doing this for all these variables, for age, income, student, credit rating, okay, till one level, and through information gain it will collect which has the, it will choose as a root node which has the highest income gain. You got my point? So it choose a student, let's say. So now it decides that a student would be on the root node. Now a student is divided into 2 nodes. Okay. Now again the question arises that this no category here, it's a, again let's say it is again a root node at this situation. Then again algorithm do the same calculation by taking age, income, CR as a root node, assumed to be as a root node, and go further, right? So it's a very heavy mathematical calculation involved into that. But algorithm, and because of the computational power, we do not realize it, because we just click on the button or we call the formula and we get the tree. Income left node, right? It tried to explain, I think, gain for tree 1, then income left node. Okay, it tried to explain for this income left node. In income left node we have 3 category: low, medium and high. Okay, then how it will calculate? So 3 upon 3 plus 4, the same way. Total how many? 1, 2, 3, 4, 5, 6, 7. Total 7 dependent variable we have in this arena, right? In this arena, 1, 2, 3, 4, 5, 6, 7. So total 3 plus 4, 7. Out of that, 1, 2, 3, 4, 5, 6. Wait a minute. Okay, it's taking the, sorry, it's taking the left node. I explain you the right node. Left node, how many observation we have in income as a root node? If income as a root node, we have 1, 2, 3, 4, 5, 6, 7. 7 dependent variable. Out of that, 1, 2, 3 and 4 are no and 3 are yes. So IPN at this node, IPN at this node, it would, now it would treat, first it decide that student would be the root node. Then at this point is try to figure it out whether income would be a root node or age would be a root node or CR would be a root node. So it's taking income at a time and calculating the IPN. Minus 3 upon 3 plus 4. Okay, in this way. And income has 2 category, high and medium in this case only, high and medium, right? So for high we have 2 no and 1 yes. So look at that. 1 upon 1 plus 2 log base 2, 1 upon 1 plus 2 minus 2 upon 1 plus 2 log base 2, 2 divided by 1 plus 2. In the same way, n sub 2 p2, that is medium. 2 yes, 2 no. So 2 divided by 2 plus 2 log base 2, 2 divided by 2 plus 2 minus 2 divided by 2 plus 2 log base 2, 2 divided by 2 plus 2. It's 2 plus 2. It's typo. So again we get information gain 1 here. So in income high, how many, if income is high, how many yes we have? 1. How many no we have? 2. Right? In medium, how many no we have? 2. How many yes we have? 2. 2. So again and try to calculate the entropy, and information gain is 0.024 in the case if we took income as a root node. Okay. So in this way it goes like that, and choose at each level. Right. And they exclaim for right node. In right we have 3 income node, low, medium, high. So even in right it would try to figure out which one is to keep, age, income or CR. So it choose the node at each level based on the information gain and based on the entropy. As the entropy is lower, the information gain is higher. So because from IPN we are subtracting the income, the entropy, sorry. Right? I think that's pretty clear.